Bismillahirrahmanirrahim. Today's video will be discussing practice problem 8.5 from Mr. Hayt's book of Engineering Circuit Analysis, 8th edition. And for this, a student from Singapore has requested. So let's see. Straight away to the question. At t is equal to 0.15 second in this circuit and figure, find the value of IL, I1 and I2. IL is the current through the inductor. I1 is this current through 8 ohm and I2 current is through the switch. And the answer is also given. So keep that in mind. Now let's start with the solution. Actually, although it's not written here, but what we need to find first of all is that we'll find at for any time t. So general equation will be t, ILT, I1t and I2t. And t denotes that for any time t, the equation should be valid. Now, I will not be following Mr. Hayt's technique, because I feel that Alexander and Sadiqu's book gives a very easy approach, and since I've been teaching from that book, I feel more comfortable in doing questions with that. So let's, in that book there are two equations. Now this is 7.20 or 7.61 for the current IL. So which one to use? Now for that, let me explain. This is for source-free circuit. And this equation is the circuit with source, or also called, it is the forced response or step response. Now, what about our circuit? Now to find which type of circuit is this, we close the switch. And then after closure, that is at t is equal to 0, if there is a source still present in the circuit, that means this circuit is the step response circuit. So we'll be using this equation. Now, actually, keeping in view the values given, so we'll write just IT as ILT, then this is IL infinity, IL0, etc. Now, what are these values? We'll discuss. Find IL0. IL0 is that for before the switch is closed at time t less than 0. Now, at time t less than 0, this switch is open, so it is open, and the inductor will behave like a short circuit because this circuit is in steady state condition, and the inductor with steady state or DC will behave like a short circuit. And so from here, we can find the current through the inductor. Now this current will be how much? This is the source. And this current is going through these two paths, no current flowing here. So we can use the current division rule, or CDR. So total current divided by total resistance multiplied by opposite arm. We want to find the current in this, so we'll multiply by the opposite arm. So I0 or IL0 is 1.6 ampere. We have found this. Now we need to find I infinity, IL infinity, and one more element called tau. So we were up to here. And keep this diagram in mind. We divide the whole process into three parts. Before 0 is steady state condition, time less than 0. And after t0, we divide it into two parts. One is called the transient period, and the other is called the steady state condition. Now the steady state condition is the infinity. So I infinity or V infinity will be the steady state condition. So for that, now the switch has been closed. I'm calling it t greater than 0, this one. t greater than 0, the switch has been closed, and the circuit is again in steady state condition like here. Therefore, inductor will again behave like a short circuit. Okay, so this current now will be called the IL infinity. And how much will that be? Let's see. 2 ampere current, all current will flow through this short circuit. No current will flow here, no current will flow through here. And therefore, we can say that I infinity will be equal to 0. So I0 and I infinity, we have found both. So now we need to find tau. What is tau? Tau is called the time constant. And for RL circuit, it is given by L divided by R or R Thevenin. So we have to find the Thevenin equivalent, R Thevenin, from this circuit. And I hope you recall that we have to be in the transient condition, not in the infinity here. We have, so the transient condition, the inductor will not be short-circuited. Switch is closed, but the inductor will not behave like a short circuit during this period. So this is the circuit, and from here we have to find R Thevenin. And I hope you recall that to find R Thevenin, we make the source 0. The current source is made 0 by opening it. So we'll open up this circuit, and from here we'll find R Thevenin. So we were up to this point trying to find R Thevenin. And now you can see this is short-circuiting the 8 ohm resistance. So we can short-circuit this. So this is the remaining circuit. And if we redraw, it will be like this. So this is the resistance and this is our inductor. So it's easy. R Thevenin is 2 ohm. R Thevenin is 2 ohm. And now we'll find tau, which is L over R Thevenin. L from here is 0.4 Henry divided by 2. It's 1 over 5 second is the tau. And now we are ready to plug in all the values. So in this equation, we plug in all the values. IL infinity 0, IL0 is 1.6, e raised to the power minus t over tau. And this can further be simplified, and the answer will be 1.6 e raised to the power minus 5t ampere. So we have found one of the currents in terms of t. Now we need to find I1t and I2t. Now since 8 ohm resistor has a short circuit in parallel, now you can see this resistor has a short circuit in parallel, no current will flow through it. This source current will not flow through this because of the short circuit. All current will flow here. Similarly, if there is a current in this energy, that current will also not flow through this. It will rather flow through the short circuit path. Therefore, we'll say that I1t current through this is 0. Now coming on to the I2t, there are two currents flowing through the short circuit. Two currents, one is 2 ampere and other is the inductor current. The inductor is an energy source and this will gradually dissipate its energy through this path. So two currents, and therefore we can say that I2t is 2 ampere minus ILT. And plugging in the value 2 ILT, we'll put this value. So this is our third equation. So we have one equation, two equations, and three equations. These are all general equations in terms of a t. Our question says that we have to find the values at t is equal to 0.15 seconds. So now in these equations, we have to find t is equal to 0.15. So the first equation, this one, 1.6, e raised to the power minus 5t, t is 0.15, and if you use your calculator, you will get the answer 0.756. If you have any doubt, let me just show you from here. One 1.6 multiplied by shift e power minus 5 multiplied by 0.15 equal sign 7557, or we write 0.756 ampere. So this is from the first equation. IT is 0, therefore I1t is 0, therefore I1 0.15 will also be 0. And then I2t from here. In this equation, now I put t is equal to 0.15. And if you solve using your calculator, the answer will be 1.244 ampere. And this is the answer given in the book, 0.756, 0 and 1.244 ampere. So I hope you have been able to follow this. Please let me know through your comments. Thank you.